What is embedded systems, and how does it differentiate from different engineering professions? What's unique about it? What's special?
Embedded computing systems are computing systems that are embedded in another application. So when you look at that application, you wouldn't necessarily think of it as a computer. The primary function is not a computer, but there's computing inside of it. Industrial automation, that's a big embedded systems, embedded computing application space. Military and aerospace, the infotainment systems in buses and trains and cars, driver assist in passenger cars, railway control, embedded systems, medical devices, so everything from the big CAT scan and MRI machines in hospitals all the way down to implanted devices could be considered embedded systems.
The daily life of an embedded systems engineer can be most closely compared with that of a software engineer. The majority amount of time is spent on code, working to program solutions to given tasks. With many of these similarities in mind, there are some deviations from other fields of engineering. Embedded systems engineers in specific may also work with hardware components and circuits, which can vary greatly in complexity and offer a wide variety of functions.
There is a greater focus in embedded computing and embedded systems on size, weight, and power. So that's an acronym that's used in industry: SWAP, size, weight, and power. Also, reliability and system availability. What's the probability that it is able to continue providing the function that it's intended to? And that comes in like telecommunications equipment. Very important that the telecommunications network stays up and running even in the presence of failures.
Looking at embedded systems and statistics, what role or roles do stats play in embedded systems, and where have you used that in your career?
With almost every system, you have to gather data on the performance of the system. So whether it's the temperature of the system, average temperature, or the tolerances on how mechanical components go together, or your software run times based on a whole bunch of varying difficult things to control. And you tend to use averages a lot for that. So the last place that I've used statistics, and this one was probably the most complex statistics, because it involved some fairly complex state machines within the computer architecture. I did a lot of modeling of performance of computer architectures to do prediction of how one architecture would run a piece of code versus how another architecture would run a piece of code. And it was all probability based, because you didn't have actual code to work with, and you were by nature you were trying to predict performance on things that didn't exist yet.
We talked about what is unique about embedded systems, but what kind of connections are there between embedded systems and other types of engineering, and then specifically too, and I know we were talking a little bit ahead of time about this, but the 14 grand challenges, if there's any relation to any of those, that you could speak on that you've worked on personally, or if there's any other embedded systems that you're aware of, just any insight you have on that.
The general discipline is the same. Now, the types of code that you write and the focus on meeting size, weight, and power requirements, that's going to be a little different.
Okay.
But and of course, you're going to work a little closer to hardware than you would if you were in like a web and mobile type situation. But the discipline is the same, and that's why there is no such thing as there's no such thing as an embedded system software engineer or a web and mobile software engineer. There's a software engineer. If you look at the broad definition of what embedded systems is, embedded systems can touch a lot of these things, but like making solar energy economical, portion of solar energy that has to do with managing the storage and the control of the optimization, efficiency, monitoring of the entire solar system, that's all embedded. So that's all it's a specific type of industrial control, which falls in the traditional embedded systems engineering scope of engineering. engineering better medicines, that's not directly related to embedded systems. However, there's another side, not on the medication side, the medicine side, but on the better health options.
Right.
I was involved in an embedded a project where we were looking at providing medical options for monitoring patients where if you were getting old and having difficulty looking after yourself, we could put some devices in your home which would help you continue to monitor yourself.
Accessibility and whatnot.
Yeah, so you wouldn't have to go to an assisted living
Right,
place. You could
right.
maintain your independence for longer.
Right.